Section 12.1, the normal distribution. The normal distribution looks like a bell and is symmetrical. It's centered around the mean with one peak. In a normal distribution, the mean, median, and mode are all the same. Because the distribution is symmetric, so there are 50% below the mean and 50% above the mean. Everything under this curve add up to be 100%. And almost all of the area under this normal distribution curve is within 3 standard deviations of the mean. Example, the test scores on a math exam are approximately normal distributed with mean 72 and standard deviation 8. Draw the associated normal distribution curve and label the axis. My data values are test scores on a math exam and that are approximately normal distributed with the mean 72 and standard deviation of 8. They want me to draw the associated normal distribution curve. A normal distribution curve looks like a bell. The mean is at the peak. So 72 is right here. Standard deviation is 8. In a normal distribution curve, almost all of the data values will be within 3 standard deviations of the mean. This number is 1 standard deviation above the mean. The distance from 72 to this number is 1 standard deviation. To find this number, I take 72 plus 1 standard deviation. And in this case, standard deviation is 8. So I take 72 plus 8 to get this number. And that is 80. This number is 2 standard deviations above the mean. The distance from 72 to this number is 2 standard deviations. So to find this number, I take 72 plus 8 plus 8, which is 88. This number is 3 standard deviations above the mean. To find this number, I take 72 plus 8 plus 8 plus 8, which is 96. This number is 1 standard deviation below the mean. To find this number, I take 72 minus 1 standard deviation. So I take 72 minus 8, I get 64. This number is 2 standard deviations below the mean. So to find this number, I take 72 minus 8 minus 8, I get 56. This number is 3 standard deviations below the mean. To find this, I take 72 minus 8 minus 8 minus 8, which is 48. This horizontal line represents the test scores on a math exam. So if I let X be the test scores, then this number line represents the value of X. 48 is 3 standard deviations below the mean. 96 is 3 standard deviations above the mean. The majority of my test scores are within 3 standard deviations of the mean. So the majority of my test scores are in between 48 96. Example 2. The test scores on a math exam are approximately normal distributed with mean 72 and standard deviation 2. Draw the associated normal distribution curve and label the axis. So my data values a test score on a math exam, and that is approximately normal distributed. Mean is 72, standard deviation is 2. Normal distribution curve has a bell shape, so I'm going to draw a bell. Let X be my test scores. The numbers on this horizontal line represent my X, which is the test scores. My mean is at the peak. 72 is right here. The majority of my test scores are within 3 standard deviations of the mean. This number is 1 standard deviation above the mean. To find this number, I take 72 plus 1 standard deviation. And standard deviation is 2, so I take 72 plus 2, which is 74. This number is 2 standard deviations above the mean. To find this number, I take 72 plus 1 standard deviation plus another 1 standard deviation, which is 72 plus 2 plus 2, which is 76. This number is 3 standard deviations above the mean. To find this number, I take 72 plus 2 plus 2 plus another 2. I get 78. This number is 1 standard deviation below the mean. I take 72 minus 2 to get this number. That is 70. This number is 2 standard deviations below the mean. To find this number, I take 72 minus 2 minus 2. I get 68. And this number is 3 standard deviations below the mean. I'll take 72 minus 2 minus 2 minus 2. I get 66. The majority of my test scores are from 66 to 78. Now, let's compare the graph between these two examples. In these two examples, we both have the test scores. We both have normal distribution. We both have the mean of 72. The only thing different is the standard deviation. The standard deviation here is 8, and the standard deviation here is 2. The standard deviation of the first example is larger than the standard deviation of the second example. That makes the range of the first example is larger than the range of the second example. The majority of the test scores on the first example are from 48 to 96, while the majority of the test scores on my second example are from 66 to 78. The horizontal distance of this first example is larger than the horizontal distance in this second example. And the area under this curve is 100%. The area under this curve is also 100%. If the second example has a shorter horizontal distance, but with the same area, what do I do to this to make the area the same? I have to increase the height of the curve. That is the reason why this curve is higher than the curve from the first example, because we have a shorter horizontal distance.